Good morning. Buenos dias, guten tag. I get the pleasure of presenting to you some of what I've learned. Unfortunately or fortunately, I've reached the point in my career where my experience can be measured in decades and not years anymore. So having spent a lot of time in automotive in discrete manufacturing, I've had the privilege of seeing implementations of IT and OT over the years and at different products and in different facilities. And so what I'm going to talk about today is a little bit of a journey down the road of MES in Industry 4.0 and how we've approached that and how specifically at Brose the challenges that we've encountered. But just to set the table for you a little bit, I want you to imagine the value stream in an automotive manufacturing plant. For Brose, as well as for other automotive manufacturers, we typically deal in metals and plastics. So there's some sort of forming operation, and then there's a series of assembly steps that we go through to make our products. So in the case of my team is specifically responsible to specify, acquire, commission, and launch capital equipment in our plants. And Brose's sales growth, we're a discrete manufacturer of door systems, seat systems, and various DC brushed and brushless motor applications, electrification. So things that were formerly fluid powered in the vehicle. So brake boosters, cooling fan modules, things that used to be run off the internal combustion engine that we're now putting in electric motors. So we have a wide variety of technology in our plants and quite a few technology domains, which is great because my team gets to live at that intersection between the science of making things and information technology. So let's dig into the journey a little bit. Why should you start with MES, or why should you implement an MES? A lot of discrete manufacturers have gone down the road of bulk data collection, so they've got a repository where they keep all this data, and then they leave it up to analysts or coordinators or engineers to analyze that. I did a little bit of informal research, and kind of the proportions that you see here were mirrored last night at the Icebreaker. I had the privilege of speaking with a few of you about how you're thinking about approaching Industry 4.0 and whether MES is a good starting point for you. But in general, when I talk to operations people, they are looking for two big things: efficiency gains and productivity improvement. Efficiency in terms of the manufacturing operation. How do we reduce scrap? How do we decrease downtime? How do we gain better human-machine interaction and performance? Those are really direct benefits that you can see in the shop floor. Productivity improvement can be more indirect. So how do I get my engineers to have actionable information that allows them to immediately make a decision, as opposed to running around and searching and cataloging flip charts and whiteboards? Anybody been in a shop floor lately where you see flip charts and whiteboards still in the shop? A few people nodding. Yeah, it's normal, right? This is where we live. We love charting on the shop floor. But really the migration to this digital data lake and being able to extract actionable information is really the transformation that we're going through. And our colleagues on the product side of the house have been doing this for 25, 30 years now. We don't put a product in a test stand or on a crash sled unless we know it's going to pass, because we've done a variety of simulations, we've done a ton of digital twinning there, and so on the product side we're very confident. But then on the process side, what I've run into is my engineers will spend their time doing a lot of paper study. They'll write a 75-page specification for the machinery that we need. We'll kind of do a 3D visualization of it with the equipment builder. We'll spend a ton of money to go ahead and industrialize and construct that equipment, and then we'll play find and fix for 6 months until we can stabilize it, right? We don't have the same capability in terms of simulation, visualization, and particularly interaction with the human beings. Our products tend to require that human element to route Bowden cables, to route wiring harnesses, things that are very difficult to automate. So for us, that interaction with the human being, that operator, is still very important. The other benefits that you tend to see, operational transparency. This is something for the middle and upper managers. You know, you get into an operations review and you spend the first 20 to 30 minutes in the meeting arguing over who's got the right data. And then you spend the next 20 minutes asking Plant Manager 1 why Plant Manager 3's information is better than Plant Manager 1's. And then you have another spirited dialogue about who's got the right data. So operational transparency is really where you gain a lot of efficiency in the management tier. You have managers who can actually take action and make decisions instead of searching and hunting for the information that they need. Mean time between failure, you've heard this. This is a key metric that I've found works really well in terms of cataloging the more indirect benefit and efficiency of my indirect staff. So maintenance technicians, a lot of our indirect labor in the shop floor, this is a really good metric because it tells us more about our break fix versus our preventative. And you'll see some more examples of that later in the presentation. The problems. So these are my big four. You have infrastructure, financial, trust, and mindset. And the two that I tend to focus on are trust and mindset. Trust, it's very difficult to get people to trust a source of data if it hasn't always been there, especially in operations. They trust their flip charts and their whiteboards. And when it comes to the stuff that I can find on this, well, we bypassed that. We didn't use that. I don't trust that. And they don't necessarily come out in those words, but it comes out in questions like, well, how do you know? Are you sure? You know, that lack of trust really undermines an implementation, because if you don't have fundamental trust in the data that's being generated in the shop, then you're already lost. There's no infrastructure project, there's no tool that's going to save you. Mindset, manufacturing people, we tend to be nuts and bolts people. We will spend days in the weeds about mechanical interfaces and the wiring in the panel and all those meaty, shop floor topics that matter so much. And then when it comes to the controls architecture or a review about how data flows are going to happen on our lines, it's maybe an hour, 2 hours. I mean, we give short shrift to probably the most important topic in an industrialization. And so that mindset change, getting people from being nuts and bolts people to bits and bytes people, a very good example of this is when my engineers are specifying a machine, they are not thinking about the number of IP addresses that they're going to have to pull for that piece of equipment, because each of those devices has to have an address that can be identified and traced in the data stream. It didn't even dawn on my engineers that we had to pull 1,100 IP addresses for one specific piece of equipment. And then if you think about that, having to specify that is something that would never happen in the old school. These are the different ways we have to think about it now. The financial and infrastructure topics are always kind of there. And I think that there's a lot of other speakers and a lot of other people who will specialize in those areas. But yes, you have to have sufficient bandwidth and infrastructure. You have to have security for your data. You have to be able to afford it, and you have to have an ROI. And that's really where I spend a lot of my time personally, is what's the ROI? How am I going to generate a business case for this? Because at the end of the day, it's very difficult for me to get to the fancy things if I can't demonstrate a concrete ROI for the plant. So what are the solutions? And I'm showing a stamping press here, so I'll give you that example in a second. Number one, on the mindset side, I don't necessarily need all my manufacturing engineers to now be software people. But they need to be able to look at a software architecture diagram and understand what they're looking at and know how to ask the level 1, level 2 questions in design. Because just like for products, for machinery it's the same. 80% of the cost of that machine is designed into it. And it's not because we just wanted it to be expensive. It's because we are finding and fixing things later after the machine's already constructed. So it's very important that the investment in our people is to upskill them on the software side, but then also to leverage the controls technology experts that are in the organization and not misappropriate them as problem solvers in the shop floor. Those controls engineers need to spend their time on architecting and implementing solutions and not problem solving in the shop. And that's a typical response in the shop floor, is we misappropriate our level 3, level 4 experts and problem solving, which this means I need to upskill my maintenance techs and my manufacturing engineers. They have to be able to do the problem solving in the shop. Systematizing, there's a raging debate in every organization about whether your Industry 4.0 or even your MES strategy should be centralized versus distributed. If I put on my plant manager hat, I'm going to say, I know my plant, I know what I need to do this, my people know what they need, and in some cases, at least in automotive, there are plant managers who are fortunate to have skilled resources that can do their own solution. To my solutions provider, partners, colleagues here in the audience, I'd like to humbly request, stay out of my plants. Don't go to the plant manager and offer them a solution just for that plant. Because the challenge is, if I start aggregating data for the entire region for which I'm responsible for in North America, I'm trying to compare and contrast 14 different facilities. And if a third of them have adopted one third-party solution, A third of them have adopted another third-party solution, and a third of them have developed their own internal thing. I have completely lost control of the operational transparency that I've cited earlier as being a key benefit to this. Does that necessarily mean I need to be centralized? No, maybe. But the balance between being decentralized and centralized for strategic purposes, that is something that has to get sorted between the operations staff and the information technology staff. Because IT has already solved this. We figured out a way to implement platforms for service and delivery for office productivity, for platform systems to do MRP. I mean, these are topics that are not new. It's just because we're focusing on the operation, it creates an element of confusion that we've never had to deal with before. But making MES part of your production system and your product development process is a key for middle and upper management. This is a policy decision. This is not a tool. It's vitally important that you treat your IT infrastructure for your project implementations as seriously as you do your real estate portfolio, the type of equipment that you're buying, and the quality and quantity of people that you're putting in the operation. And a lot of times there will be single point events. Okay, we have this MES concept file, and it's a deliverable in our product development process, and we've completed it, we've checked the box. And then the changes come in the products, or we do diversification, or we introduce a new model, or something happens later. And as with many cases, there's a lack of feedback into the system to say, well, now we have to modify our MES concept because we've changed either the model, or we've introduced a new variant, or we've done something different that requires us to go back. And we have mechanisms to do that for drawings, for specifications, for supplier quotations, all these things. But again, the IT side tends to get short shrift in those discussions. Monetization is the fun part, because if you actually get to the point where you're successful in implementing a platform, you can offer benefits to your customers. There's one case in automotive where an MES implementation went very well, and the crux was for traceability purposes. The business case was a traceability system. The customer was pulling for more higher traceability, which required implementation earlier in the manufacturing value stream. And this company very smartly said, yes, we can do that. How much are you willing to pay for that? And the customer, because it was a safety critical component, was willing to pay for that. So this type of technology does introduce these new business models and new revenue streams that you can monetize. The trick is not to jump too far too fast, because if your sales team offers it and the customer pays you for it, then there's a very high expectation that you will deliver it. And for those of you that are just kind of starting on this journey, it's a big elephant to eat, and if you try to do it too far too fast, it'll consume quite a bit of your time and resources. The stamping press example. That was specifically the monetization aspect. So imagine the value stream: metalworking, stamping, welding, painting, assembly. Our traceability system starts in assembly. I apply a barcode and I can trace everything forward, but this is a safety critical component. It's welded. My welds can't break. So customer says, I want higher traceability. I want to know that your welding process remains stable. I don't want to know that your assemblies are good. I want to know that your weld joints down to that individual weld seam are good. And this required us to introduce new process monitoring technology, and it also required us to upgrade our traceability system. And that led to a bit of a middleware dilemma for us. So we had a quality control process that was run in the lab. We had a MES interface on the shop floor to the PLCs, and then our MRP system was talking to the quality lab to say, release this material for production. And we didn't have communication between those three systems. And it was triggered, that gap was all triggered by this desire to increase our traceability earlier in the value stream. Caused a lot of consternation, required us to develop some middleware to fix that. But these are the types of challenges where if you jump too far too fast or you sell it too early, that's where you run into some trouble. You've heard a lot about solutions being agnostic to your platforms. This is no different. It's very important that from a data migration point of view, you're able to migrate quickly from one MES platform to another. It's very important that your modules be compatible with different platforms. Simple example, my machine builders do all of their machine design in SolidWorks. Our products are designed in CATIA, and my controls platform are Siemens PLCs. How am I going to connect all that information together in a digital thread? And oh, by the way, all of my products are designed in-house in CATIA, but all my machinery is designed out of house within a supply base. So integrating all that data into a true digital thread has been a very big challenge for us, and that's why MES was the starting point, because that's the data lake I want to build to feed virtualization of my process planning. Because right now, I'm heavily dependent on my suppliers, my equipment builders. Legacy manufacturing equipment, you heard some really good examples from the colleagues from NOV about how to retrofit older equipment, but that does deserve your attention. But more so, the MES PCs, the actual hardware you're going to implement on the shop floor, these need to be treated as an expense, not an investment. They need to be planned. You cannot have a reactionary strategy. Just like in the office, you can't be bulldozing your PCs and having them as a depreciated asset, and then of course we ride them until they die, right? We want to bulldoze those on a regular basis, give people the best productivity tools possible. For MES PCs, it's no different. And those industrial PCs, they are the lifeblood of the data collection and presentation to your shop floor employees. So don't forget, yeah, we're talking about all the devices on the manufacturing equipment, but the actual interface for the human being, that MES PC or that HMI is equally important and needs to be addressed in your strategy. IT, this is a bit of a controversial statement. I know that there are a lot of people who are like, oh, Joe, there's already 40 people that are involved in our process planning. I have to go for so many approvals. Yeah, well, but now you're adding a layer that has never been addressed before, and you're not equipped for it. I've already said, right, I've got nuts and bolts people, not bits and bytes people. I need bits and bytes people to be looking at our production systems and ensuring that we've accounted for all the requirements for any application ownership, service and delivery support, and escalation protocol. And those are things that come by surprise when you start ramping up a line and all of a sudden an application goes down on a machine on the shop floor, and you call IT or you put in a ticket and they're like, what is this? It's brutal to try to recover from that. Middleware make versus buy, this is also something that's been touched on by a couple of the other speakers. You know, having a clear case where you want to develop your own versus going out of house, you have to spend the time to think about that. The middleware solution that we've concocted for ours is an interim measure, so we've decided to make because we don't have the time frame right now to buy and integrate, so we're gonna take a phased approach. But it's a continuum, as with many things. Assess your time frame and see what you can do yourself versus buying. And the welding example that you see here, we do a lot of laser welding on our seat structures. The process monitoring technology that we put in there was a big enabler for us to have the MES be successful for the traceability system. So an implementation model, and I'm not going to read all this to you, but the bottom line here is if you're just starting, what's vitally important is that you don't shoehorn the implementation into a project cycle. You have enough challenges in the daily work trying to deliver a project, and if you try to shoehorn an implementation into your project cycle, you better be prepared to deploy massive resources in order to contain that implementation. So what does that look like in automotive? Our product cycles are typically 2 to 3 years. We're a backlog business. We book a program, and then 2 years later, we should be ramping up production, some 2 to 3 years later. So we have that window to figure out what we're going to do and how we're going to do it. And unfortunately, it doesn't lend itself well to a platform project for MES implementation. We already have to have the platform defined and how this project is going to sit on top of the existing platform. We really can't spend the time to say, for this project and its unique requirements, we need to define a specific IT solution. We'll never finish it in time because in the background, we have running production that has to be maintained and that requires a certain amount of resources. For people in plants, this is a topic I'm really passionate about. Your key users or your power users for SAP, for all the interfacing systems is where you're going to find your core of people. Who are your power users in controls technology? Who are your power users for SAP or whatever your MRP or ERP or your environment basis is sitting? Who are those people that are the power users? They are the ones that are going to help you build a core of know-how for MES implementation or any other module for that matter. But it's vitally important that you find them, that you retain them, and that you have them training others. The pilot plants, this is also a lot of fun. I find that making this a competitive process is best. Have the plants competing with each other to be the first, as opposed to whoever didn't take 2 steps back when asked for volunteers is the one that gets to go. If you make it more competitive and frame it as we're going to make an investment in your shop, we're going to have you extracting productivity benefits, operational transparency, you're going to have more productivity, you're going to have lower overhead. Presenting it more as a pitch to the operation tends to generate more pull, and they want to actually be part of it as opposed to the push method where you're trying to convince them, cajole them, prod them, poke them. These are things that tend to not work so well. For projects, when you finally do get to the point where you want to do an implementation, again, avoid selling too soon and test new benefits outside your project cycle. You know, really make it asynchronous between your enhancements to your MES or your platform. Don't leverage the projects because, again, that's where you get launch disruptions, especially in discrete manufacturing. Test in a virtual environment, test your new benefits, and then pick and choose your projects, and then go for the full way. A lot of times we try to just wholesale implement new things. That works in an office productivity environment, but in the shop floor it can be very disruptive. So I would say, you know, choose your projects wisely about where you test drive your new benefits. Finally, and this is where the fun begins, the reason we picked MES first is because it gives us the operational transparency and data visibility to enable other Industry 4.0 technologies. I'm a big additive manufacturing fan, and while a lot of the industry has been talking about how do we get to direct digital manufacturing, I view additive as an enabler for maintenance and limited use tooling, fixtures, these types of things, work holding. So for example, I have a lot of work holding fixtures for which I have to maintain a significant amount of inventory just in case. But if I know what those wear and tear parts are, and I have tracking on the MES about how many cycles are on them, or how much wear and tear I've absorbed, or if I have wear features that can be recognized by a vision system that feed the MES, I can manufacture those on demand, or I can send work orders to the machine shop if it's internal, or external if I have to write a PO and get the machine shop running. I can fabricate those details on demand. The last estimate I saw is that tooling and work holding is about an 8 billion euro business. So tooling and work holding, if you think about that, in addition, part of that 8 billion is spares and wares that are just sitting on a shelf, you know, high durable goods that are just sitting there just in case. If your plants didn't need that much spare parts stock and freed up all that capital, what could you do with that? So really, the data lake feeding the digital twin or feeding the AI engines, you know, you heard the examples earlier. This is why MES was first, at least for us. It gave us the opportunity to now build on top it's an enabler for these other Industry 4.0 technologies that are also very powerful. That's all I have. I'll be happy to take any questions. It's been a lot of fun, and I hope it was informative for you. Thank you.